We are mapping the exact point where the manual labor of routing logic is absorbed by automated computation. The prevailing assumption across the tech sector is that AI coding agents are tools built by software engineers, explicitly designed to help other engineers write code faster. To test that assumption empirically, we have to look at the dataset of Claude Code interactions. This visualization tracks 400,000 distinct agentic sessions logged between October 2025 and April 2026. By analyzing this telemetry data, we can dissect the mechanical reality of these sessions and measure the behavioral economics of how humans and AI actually divide the labor. The data reveals a structural decoupling. The act of creating software is separating from the profession of software engineering. The limiting factor in building digital infrastructure is no longer a human's ability to manually write syntax. The new bottleneck is a user's ability to accurately define the problem domain. Agentic AI does not function as a simple software update for developers. It restructures who actually has the capacity to build digital tools. To understand this structural shift, we scale down from the macro dataset to examine a micro-level interaction between a single user and the Claude agent. This illustrates a turn. A single prompt triggers the AI to read files, edit code, and run commands. That prompt multiplies into 10 autonomous actions, generating 2,400 words of output. To determine who controls this, we apply decision attribution. The data divides decisions into two categories. Planning involves the human deciding what to build, determining the approach to take, and defining what constitutes success. Execution involves the AI determining exactly how to build it, mapping file routing, running operations, and generating syntax. Across these sessions, humans make 70% of the planning decisions, while the AI makes 80% of execution decisions. In an agentic workflow, the human is promoted from a general contractor executing the labor to an architect defining the parameters. If the human is strictly the architect, we must look at what happens to the agent's output when that architect provides superior instructions. The system rates user interactions on a 5-point task-specific expertise scale. This scale evaluates problem spares, how precisely a user frames a problem, whether they anticipate edge cases, and what they ask the AI to verify. It does not measure the user's job title or general intelligence. There is a sharp qualitative difference here. A novice provides generic instructions like create a tool. An expert provides strict reconciliation rules and demands specific edge case handling based on their knowledge of a specific business process. This chart shows the quantitative result. A novice prompt triggers 5 actions and 600 words. An expert prompt pushes that to 12 actions and over 3,000 words. Deep domain knowledge triggers action chains twice as long, producing 5 times the output. Without that rigorous human framing, the agent remains artificially constrained, regardless of the underlying model's raw power. The ultimate bottleneck to agentic output is the human's inability to rigorously map our own domain space. In this environment, expertise commands the machine. To test the actual utility of this expertise, we evaluate these sessions against the metric of verified success. This requires hard evidence, code that successfully compiles, passes testing suites, and is successfully committed. This chart ranks coding success by occupation. The top 10 occupational groups fall within a narrow 7-point spread. Non-software roles succeed at nearly the identical rate as professional engineers. An anomaly sits at the top. Management actually pushes past the computer science baseline. This happens because managers frequently possess highly transferable skills perfectly suited for an agentic workflow: task delegation, strict specification writing, and outcome verification. Furthermore, deep specialization is not required to achieve these results. The success metrics reveal an intermediate plateau. The leap from a novice to an intermediate level of domain expertise provides massive gains in verified success, but the jump from intermediate to true expert yields only a modest, marginal improvement. A competent working grasp of a domain is sufficient to bypass the need for syntax mastery. Software creation is no longer gated by a specific engineering background. This decoupled dynamic between human planning and AI execution shifted the entire composition of knowledge work over the 7 months measured in the dataset. This chart tracks the sharp decline in low-level implementation. Over 7 months, sessions spent fixing broken code plummeted from 33 to 19%. Concurrently, higher-order workflows rose. Operating systems, analyzing data, and writing prose roughly doubled over that same timeline. This behavioral shift directly correlates with a 25% increase in the estimated economic value of the typical task being performed by the agent. As the AI successfully absorbs the friction and cost of technical implementation, it frees human capital to focus entirely on high-value orchestration. Agentic tools do not replace human domain expertise. They specifically replace the mechanical, specialized act of writing code. The immediate labor market implication is clear. The pure, isolated ability to write syntax will face severe economic discounting. The market will aggressively reward those who too rigidly define a problem, anticipate its edge cases, and verify complex outcomes across any specific industry. Technical implementation is being automated. Those who deeply understand their business domain will become the ultimate autonomous builders.